Good afternoon. This lesson is all about binary arithmetic. It looks complicated, but it's a lot easier than you think because it's actually almost identical to the type of adding that you've done at primary school. So we're going to go through lots of worked examples. You need to have your purple spotty book out, open in front of you with a pencil in your hand, please. By the end of today, you need to know what we mean by bits, the fact that 8 of those bits altogether makes 1 byte. And if you have two 8-bit binary numbers, we should be able to add them together. So we're going to do some binary addition. Sometimes that will give us a problem known as an overflow error, and we need to know what that means, how to recognize it, and the implications for the real world. So, at primary school, that's about as difficult as we need to get in today's lesson. But let's switch first of all to the way that we did maths at primary school. So you've hopefully got your spotty books. There we go. Can we turn to a new page, please? Ooh, don't want that cable in front there. Sorry if it's wobbling. That'll do. The topic is binary addition. Today's date is the 25th. We want to recap how we do addition without binary, first of all. So if we have a really simple number like 3 plus 4, at primary school you were taught to write them on top of each other, column addition. And we do 3 plus 4 is 7. Nice and easy, okay? It gets slightly more complicated at primary school if you have bigger numbers like 13 plus 22. And if that is the case, do we start adding on the right or do we start adding on the left? Yeah, we start on the right. So we go 3 plus 2 is 5, and we write the answer underneath, and we do 1 plus 2 is 3, and we've got the answer. Okay, still no concerns at the moment. It does get slightly more complicated if we have to carry things over. Like this time, let's say 13 plus 29. It's still only 2 digits, but we do 3 plus 9. Oh, we can't represent that with 1 digit anymore. That's 12. So we write 2, and we carry the 1. Nothing new here. We just have to remember to add that carry to what we've got over here. 1 plus 2 is 3. Add the carry is 4. Okay? No surprises. You've done this in maths from a very early age. This is denary addition. Why do we call it denary? Because there are 10 different digits that you can have. I'm not going to be able to write them and talk at the same time. 10 different ones, starting at 0 up to 9. 10 different ones. Sometimes you see it written as decimal, sometimes denary. Officially it should be denary. There we go. Right, binary is the same, but it's much easier because you can either have 0 plus 0, which is 0. You can have 0 plus 1, which is 1. You can have 1 plus 0, which is still 1. Or 1 plus 1, which is 2, but we can't write 2 in binary. Or can we? Well, actually we can. How do we write 2 in binary? So we do that by saying 0 and carry the 1. So that's my explanation. You don't need to write that. What you do need to write is this first example. So let's write this out. This is a binary byte, 8 bits. So let's do 1, 0, 1, 0, 1, 0, 1, 0. That is 1 byte, 8 bits in binary. If we add the binary number 1, 1 and all of the rest zeros, making sure it's column addition. So we do each bit lined up in columns. I'm going to write a little plus there just to tell us that we're doing addition, adding. Draw a line underneath. You're not going to like me if you're a perfectionist because you'll want to use a ruler, sorry. And again we start on the right and we just say 0 plus 1 is 1. 1 plus 1 is 2. We can't write 2 in binary unless we use 2 bits. So 2 in binary is 1, 0, as in 0, and carry the 1. It's exactly the same, but much simpler because we've only got zeros and ones. 0 plus 1 is 1. Okay, I'd like you to shout out for this, please. 1 plus 0 is correct. 0 plus 0 is, thank you. 1 plus 0 is 0 plus 0 is good. And 1 plus 0 is 1. Okay. Now let's check them. Along the top, let's work out the bit values. Yeah, so the least significant bit, the one that's only worth 1, is on the right, and the most significant bit is on the left. And we double each time. 1, 2, 4, 8, 16, 32, 64, and 128. So I'm going to write down in the margin over here what each of these are. Oh gosh, it's going to test my mental arithmetic. 2 plus 8 is 10. 10 plus 32 is 42. And then 42 plus 128 is 170. Is that right? Hope so. Tell me if I get it wrong. What's this one? Class chart's positive question. So this one here is 3 because we've got a 1 plus a 2. If we were doing this in denary, we would expect 170 plus 3 to be 173, yes? Should we just check my maths? Because I'm not feeling very confident at the end of a long day. Let's see. 1. No, I'm not going to add the 1 because we've got a 0 there. 2 plus 8 plus 32 plus 128. Oh, thank goodness. Okay, so we've done a little bit of a sanity check here. We've worked these out in denary, we've added them together, and then in theory, if we do 128 plus 32 plus 8 plus 4 plus 1, we should get 173. Can you work that in your head and give me a thumbs up or a thumbs down if you agree if that is correct or not? Yeah, there's a few thumbs up. There's a few people waiting for everyone else to do the hard work. So, activity 1 is easier than what we've just done. What we're going to do, start on the right. 1 plus 1 is 2. So how do we do that? Well, it's 0, carry the 1. Now, I really don't like doing this just in Word. So, get your purple spotty book for your work in. Write out your values. What have we got? 1, 0, 0, 1 plus 0, 0, 1, 1. Take your time. I know you can probably do them in your head, but in an exam you might feel under pressure, and you've got plenty of time. No one ever runs out of time. 1 plus 1 is 2, which means 1, 0. 1 plus 1 is 2. 0, carry 1. 0 plus 0 plus 1 is 1. 1 plus 0, no carry, is just 1. And at that point, I'm going to write that in here. 1, 1, 0, 0. Nice. Then we'll check. What is 1, 0, 0, 1? 1, 2, 4, and 8. It's 8 plus 1, which is 9. Okay? What is 0, 0, 1, 1? It's 3. What is 9 plus 3? It's 12. Is that the same as 8 plus 4? Yes, it is. They're both equal to 12, so we've got it right. All right, I've done 1. You've got 3 more. Off you go. All right, we're going to go through a couple of examples here and explain the concept of an overflow. So far, we've said if we have simple numbers, like 1 plus 1 is 2, let's just prove that 1 plus 1 is 2. 1 plus 1 is 0, carry the 1. That carry gets added to these. And we end up with, if this is 1 in binary, it's also 1 in denary. 1 in binary is 1 in denary, but 1, 0 in binary is 2 in denary. It works. However, if we're just sticking with those 4 bits, this time, in fact, I'm going to go onto a new page so it's easier for you to see. What about 1, 0, 1, 1 plus 1, 0, 0, 1? Okay, let's first of all work out what these are in denary. 1, 2, 4, and 8. 1 plus 2 is 3. 3 plus 8 is 11. 1 plus 8 is 9. Add the two together, we should have 20. No problems yet. However, if we add them together in binary, 1 plus 1 is 2, which is 1, 0, so 0, carry the 1. 1 plus 1 is 2 again, 0, carry that 1. This time we've got 0 plus 0, we've got a 1 there. And we've now got 1 plus 1 is 2. Oh, well, we've got an extra carry over there. in order to represent this number properly, we're going to need a whole extra bit. If we've only got a limited number of bits to do it, we're going to say that 11 plus 9 is equal to 4. And that's not correct, is it? To properly store it, we have to have that 1 there. But if you've only got a 4-bit computer, that's a problem. And this can be a significant issue. We call that an overflow bit. It might be even more significant than that. Let's have a look. 1111 plus 1, all in binary. Let's add them together. 1 plus 1 is 2. 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 So now we've said 15 plus 1 is 0, which is an overflow error if our computer is only capable of storing 4 bits. We know it's not 0, we know it's actually 16, and there's an extra bit there. I think we've had an excellent question in the class, which is if we have something like these added together, 15 plus 15, add them together, we've got 1 plus 1 is 2, and look what we've got here. 1 plus 1 plus 1, well that's 3. How do we write 3 in binary? Well, it's just 1, 1, isn't it? 1 and carry the 1. 1 plus 1 plus that carry is 3. Do you get the idea? So this overflow tells us that there's a potential for a significant problem if our computer only has a limited number of bits to store. Okay, so for activity 2, we've gone through how to put these carries in, and we've established that we haven't got enough bits to store the answer here. We need this overflow. Let's use a calculator, bearing in mind you're not allowed to use a calculator in the exam. And if we change the mode from scientific to programmer, we can now work in binary. So let's add the numbers in. 1, 1, 0, 0, 0, 1, 1, 1, plus 1, 1, 1, 1, 0, 1, 0, 0, equals. So this has put it in to have an extra 4 bits to store it. But what if we told the calculator to only work with a byte, 8 bits? Let's try it again. 1, 1, 0, 0, 0, 1, 1, 1, plus 1, 1, 1, 1, 0, 1, 0, 0. And the answer, oh my goodness, it's gone crazy. The answer has suddenly become loads of 1s and a negative number. That's what happened on the Ariane 5 spaceship in the video that we showed in lessons. It suddenly thinks it's gone from a big positive number into a big negative number. And we'll deal with negative numbers next lesson. So I'd like you to have a go at that yourself and then attempt to answer these 3 bullet point questions. Okay, so we want to try and write a Python program that will test these for us. It will say, please enter a binary number, and we'll type it in without any spaces. And it will say, please enter another binary number, and we'll type this in without any spaces. And then it will tell us what that binary number was in denary, what that binary number was in denary, what the 2 numbers added together are in denary, and what that number added together is in binary. It's quite a lot involved there. So let's see if we can decompose that. First of all, ask for a binary number. We want to do that twice. We want to convert to denary. We want to do that twice. And then we want to add the 2 together and display the result. We also want to display the result in both binary and denary. Okay. Let's see if we can get some class charts positives. Yes, we're going to use input to ask the question. Oops, if you can spell it helps. And we're going to do that twice. Notice I always leave a blank line above the comment, unless it's on the top line, just so that it's crystal clear that the comment is referring to the line underneath. We can't convert this to denary yet because we haven't listened to the answer. So let's call it binary number 1. And then we'll do the same for binary number 2. Nice. We need to convert that number to denary, so let's call it denary number 1 is equal to... Now, how are we going to do this? First of all, we have to convert it from a string to a... can we go straight to the denary value? Will that work? Don't know. We'll see. If we convert that to an integer, base 2, let's check and see if this works. So print, let's display that and see if it works. Let's put 101. Great, it's converted to 5. How about 1000? We're hoping that would be not 1, not 1, not 2, not 4, but it should be 8. That's quite exciting. It works. Don't want to print it yet. Just want to repeat it. Convert that to denary, but there's one change. We're getting there. We now need to add the two numbers together. So I'm going to call it sum in denary, or let's go denary total. There we go. Equals denary number 1 plus denary number 2. Display the result in denary. Nice. Print denary number 2, no denary total. And then finally, display the result in binary. Let's see, 101 plus 010 should be... Ooh, we have a problem here. Some debugging necessary. Yeah, so on line 9, I've copied and pasted without changing this. Let's try again. 101 plus 010 should be 111, which is 7. Nice. But it doesn't yet display that in binary. So can we do binary total equals, and just convert it to binary with bin? Will that work? Well, it will, but it won't look very nice. And it hasn't displayed it. Why not? We must tell it to display bin total. Let's try this. 010 plus 101. It has worked. We've just got that nasty 0b in front of it, which is rather annoying. I'm not going to tell you how to get rid of that. We can get rid of it. Everything's possible in Python, but we haven't learned the bit of Python to get rid of it yet. So what is your extension challenge? I'm going to save this with you, but I'm going to ask you to practice your debugging. So this is the link that I will share with you. Put it in the description in the YouTube video if you're watching at home. I want you to click on debug, and it's been sabotaged. There are 5 mistakes on here, so if you run it, it's not going to work properly. Let's see, 1000 plus 1001. Is that correct? I don't know. Has it been sabotaged? Check your debugging skills, please. I will share this link with all of you now.